Jai Hind, Vande Mataram. This is Kunal Mehta from Make Me Scientific, and in this video I am going to solve few questions related to the center of mass, right? And this is basically the questions which are taken from ISC textbook of Newton. Okay, so before we start, let's go ahead with some of the basic formulas for the center of mass. So suppose you are given few particles, like this is say for example y-axis and this is x-axis, and you are given system of two particles, say. So if there are two particles, I'll call the mass of this as m1, the mass of this as m2, the x coordinate is x1, the y coordinate is y1, the y and x coordinate are x2 and y2 of particle number 2 having mass m2. Then the center of mass would be on the line joining them, and it is basically towards the heavier mass. And then the x coordinate of the center of mass is xcm, and the y coordinate is ycm, and x coordinate xcm is given by x1 m1 x1 plus m2 x2 divided by m1 plus m2. And if there are three particles, we will add one more term, m3 x3 upon m1 plus, sorry, this is m2 and plus m3. Three masses will come over here. Okay, in the same way, if there are multiple particles, this will go till say n particles are there, then mn xn divided by m3 plus m4 dot 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 till mn. Okay, in the same way, y coordinate of the center of mass is given by m1 y1 plus m2 y2, so on till we reach mn yn divided by m1 plus m2 till mn. Alright, in the same way we can also write the equation for z coordinate as well. Okay, once we differentiate this equation with respect to time, so d by dt of xcm, we will get v xcm. That means the coordinate, the velocity, the instantaneous velocity coordinate we are going to get when we differentiate x coordinate, right? So this will be basically, we will get m1 v1 plus m2 v2 till mn vn divided by m1 plus m2 till mn. In the same way, you can also find out ycm. So this will be vy cm, and then again you will get m1 v1 plus m2 v2 plus till mn vn divided by m1 plus m2, like that. But this is basically vx1, this is vx2. So these are the velocities in x direction, and now these are the velocities in y direction. So I should better write down this as vy1, vy2 and so on. Okay, now if you differentiate this equation one more time, you will get the formula for acceleration of the center of mass. So acceleration of center of mass, if I differentiate x coordinate of the center of mass of all the bodies, then I will get m1 a1 plus m2 a2 so on divided by m1 plus m2 so on. Okay, if I differentiate y, the y coordinate of the acceleration at any given time, then I will get acm along y axis as well. Okay, so let's keep these equations in our mind and let's solve the first numerical. So two particles of the masses of mass is 1 kg, so this is 1 kg and 4 kg are given to you. And by the way, we do understand that if you join the centers of both the spheres and more towards the heavier mass, the center of mass would be lying somewhere over here. Okay, we do know that. But now, since the coordinates are not given, so for my easiness, I am going to consider the center of any one of the spheres, basically the first sphere, to be at the origin. So 0, 0, and what would be the coordinate of this one? It will be 1, 0, because the distance between both of them is 1 meter. like this. So the center of the another sphere lies at 1 0. Okay. Now let's find the center of mass. And by the way, the center of mass would be purely on x-axis because both the point masses, okay, you can let go of the entire big spheres and consider them as point masses. Since the particles are on x-axis, so their center of mass is also on x-axis. So please do not worry about the y coordinate of the center of mass. So xcm is equal to m1x1 plus m2x2 upon m1 plus m2. So basically, I'm supposed to write down this as 1 kg times x coordinate of the first mass is 0 plus 4 kg times 1 meter divided by 1 kg plus 4 kg, that is 5 kg. So basically, kg gets cancelled and 4 by 5, right? That is 4 by 5 meter. That is what? 5 4s are 5 8s are 40. So this is 0.8 meters. So that means the center of mass is going to lie at 0.8 meters away from the origin or from the center of the first ball or the first sphere. Let's go ahead. 3 point masses 1 gram, 2 gram and 3 gram lie on xy plane. So basically when we say xy plane, this is x-axis, this is y-axis, right? The first particle is at 1 2, so this is 1 and 2, so this is 2 and 1. So say for example this is the first particle having mass 1 gram. The second particle lies on x coordinate is 0, y coordinate is -1, so basically it lies somewhere over here. This is 2 gram mass, and then but I'm just trying to explain you, but the diagram is purely not required. You are not supposed to draw the diagram. I'm just explaining this to you. This question will get over within a minute, but still I want to explain this to you in a greater detail. So 2 3, so that means x coordinate is 2 and the y coordinate is 3 minus 3, so that means the third mass is somewhere over here, that is 3 gram mass, correct? And now since we know x1 y1, this is x2 y2, this is x3 y3, so the center of mass of all of them is going to be lying somewhere on the xy plane itself. Let's find the coordinates. xcm is equal to m1x1 plus m2x2 plus m3x3 upon m1 plus m2 plus m3. So simply I'm going to substitute the value 1 gram into x coordinate is 1 plus m2 is 2 gram multiplied by x coordinate is 0 plus 3 gram times the x coordinate is going to be, the x coordinate is 2, correct, divided by the sum of the mass is 3 plus 2 plus 1, so basically this is 6. Okay, so now let's find out, let's solve this. xcm is equal to 1 plus 1, so 3 plus 2, 3 2s are 6 plus 1 7, 7 by 6 is the x coordinate in centimeters. Let's find out ycm. ycm is equal to m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3, and let's substitute the value. M1 is 1 gram and its y coordinate is 2 plus m2 is 2 gram times y coordinate is -1. Please be very careful in the sign, right? And m3 is 3 gram times x coordinate is, sorry, y coordinate is -3 upon m1 plus m2 plus m3 is 6 grams. So ycm is equal to 2 minus 2 minus 9 upon 6. So it is -9 by 6. So 3 3s are 3 2s are, so it is -3 by 2. So if I want to write down the x and y coordinate of the center of mass, it is xcm comma ycm, that is equal to 7 by 6 minus 3 by 2. If you want to write down the coordinates in terms of coordinate, basically if you want to write it down, then you can write down rcm is equal to 7 by 6 I cap minus 3 by 2 j cap. That's the answer to the problem, correct? Let's move ahead. And now you have 3 point masses and the it's given that all the 3-point masses are on equilateral triangle, and the masses are 2 grams, 3 grams, and 4 grams. Okay, so let me take this as 2 gram, 3 gram, and 4 grams, right? I'm going to consider them in a proper sequence. Yeah, it might happen that you might get different answers over here, right? It depends upon, because the center of mass depends upon the location of the arrangement of the masses. I am considering 2, 3, and 4. If you consider the origin one as 4, 3, and 2, you will get different answers. So that's completely fine if you get different answers, because it depends upon the arrangement. Usually, you are supposed to place the first ball that is of mass 2 gram at the origin, right? 2, 3, 4 sequence wise you may arrange, but that's totally fine, right? So now what is going to happen is, let's write the coordinates. So the coordinates of the first mass is going to be 0, 0. The coordinate of the second mass is going to be 1, 0. Correct. Now the third one, if I drop a perpendicular line, this is 90 degree, and since it is an equilateral triangle, this is 60 degree. So I may be able to find this as half meter. How come? Because this distance, okay, let me call this as AB. So AB distance is equal to 1 meter times cos of 60 degree, right? And 1 meter is this distance. Okay, let me call this as AC. So AB can also be written as AC times cos 60 degree. I think cos 60 is equal to, you can very well find it out, that AB upon AC, okay, from that small triangle ABC. Okay, so I'll find out AB, that is equal to 1 meter into cos 60 is half. So answer is 0.5 meter, or that means I know the x coordinate. I know the x coordinate of this ball, that is half. Now talking about the y coordinate, I am supposed to find out this distance, that is BC. Now how can I find out BC? So BC, that is equal to AC sine of 60 degree, because sine 60 is equal to perpendicular upon hypotenuse, so it is BC upon AC. Correct. You may use Pythagoras theorem in order to find the distances. That's totally fine. This is 1 meter into root 3 by 2. So I'm simply going to write this as root 3 by 2 meters. Correct. So now I also know this distance. So that means this distance is also root 3 by 2. So that makes the y coordinate as root 3 by 2. Correct. Now since I know the coordinates, I can very well go ahead. I can very well go ahead with the coordinates as well. So let's go ahead. Now XCM, that is equal to M1 X1 plus M2 X2 plus M3 X3 upon M1 plus M2 plus M3. Let's plug in the values. M1 is 2 gram. So 2 multiplied by X coordinate is 0, right? Because this is X1, Y1, this is X2, Y2, and this is X3, Y3. Correct? Plus M2 X2, so that is equal to 3 times 1 plus 4 grams multiplied by half. And the sum of the masses is 4 plus 3 plus 2. So 4 plus 3, 9 plus 3, 7 plus 2, 9. So, sorry. So 3 plus 2 by 9. So 5 by 9 is the center of mass x coordinate, right, in centimeters. And now let's find out YCM. So YCM, that is equal to M1 Y1. So straight away I'm going to put the value 2 into 0 plus M2 Y2. So 3 into 0 plus 4 into root 3 by 2 divided by the total mass is 9. So this is equal to 2 root 3 upon 9. Okay, so simply I don't want to rationalize any number. So x comma y of the center of mass is equal to, x coordinate is 5 by 9 and 2 root 3 by 9 are the coordinates of center of masses. Again I am saying this answer will differ if you interchange the position of the balls. Correct. But I just wanted you to understand how to find out the coordinates of the particle having mass m3. Correct. Let's go ahead. Now, 3 identical spheres ABC, each of radius r, are placed touching one another. So please do not make diagrams like this. All three are not touching one another. Only two balls at a time are touching one another. Here in the question are said one another touching all the three. That means this is the proper arrangement, right? So let me remove these three diagrams and let's go ahead. So these three balls are touching one another. And now when the question about the bigger balls are asked, we will only consider the larger sphere's center of mass. Correct? So for me, this is the particle having mass m1, this is the particle having mass m2, mass m3. So this actually becomes the question that we solved earlier, the triangle one, right? So what is the center of mass? Where is the center of mass located? Okay. Now you are supposed to find out the answer in terms of the radius itself, correct? By the way, this distance is, okay, let me use the red mark, the red pen, it would be more easier for you to see. Okay, so this distance is basically twice of r, and the distance from here to here is again 2r, and the distance from here to here is again 2r, because the radius of single sphere is r, correct? So if I want to write down the coordinates for mass m1, that is 0 0, because it is located at the origin. For mass m2, I should be writing x coordinate as 0 and the y coordinate as 2r. And just now we had discussed that mass 3 coordinates will be, if I drop a perpendicular line, the x coordinate will be half of 2r, so it is only r, correct? And again, this would be an equilateral triangle, so 60 degree. So the y coordinate would be equal to, okay, let me find out the y coordinate. So the y coordinate would be equal to sine 60 degree, that is equal to perpendicular upon hypotenuse. So this is ABC. So that is equal to perpendicular upon hypotenuse, that is AC. So root 3 by 2, that is equal to BC. That is what I am supposed to find out upon 2r. So basically, this is 2 getting cancelled, root 3r are the coordinates, correct? Now simply I am supposed to find out the XCM. So XCM is equal to m1 x1. So, and three identical spheres, so all of them will have same mass. So m, and this is m1 at 0, so multiplied by 0, plus m2 is again m with its x coordinate on 0, and then the third one, that is m3, so plus m times the x coordinate is r, it is half of 2r, so it is r, right? And divided by the sum of three masses, that is 3m. So XCM is basically r by 3, correct? Because it is m upon 3m times r. So mm gets cancelled, so this is the x coordinate. In the same way, let me find out YCM. So YCM, that is equal to m into y coordinate is 0 plus m into again 0, the second, because both the masses m1 and m2 are located on x-axis, plus I should write down m3, and m3 is simply m, but its y coordinate we have just now found out, that is equal to root 3r. So root 3 times r divided by 3m. So YCM is equal to, mm gets cancelled, so it is r by root 3. So we have found out x and y coordinates of the center of mass, that is equal to, x coordinate is r by 3 and this is r upon root 3. That is the answer to our problem.